Unlocking ScoliGenes, Genetic Secrets for Better Treatment Results. This book looks at how each of these genetic variants affect or disrupt body processes in digestion, hormone metabolism, neurotransmitter production, bone development, and detoxification. These combinations of genetic variant patterns, among others, combine to produce and create the condition known as Adolescent Idiopathic Scoliosis, AIS. I never intended to become a scoliosis guru when I decided to pursue a career in chiropractic medicine, and I certainly never thought I would end up writing a book on the genetic causes of adolescent idiopathic scoliosis. But, as fate would have it, we meet here, in the pages of this book, in hopes of reaching the end of a story started over 3,500 years ago by Hippocrates himself. Much of the information contained in this is based on a multi-genetic variant group study I co-authored and published in 2019, and have subsequently built upon with additional singular genetic variant studies on adolescent idiopathic scoliosis since that time. Throughout medical history, idiopathic scoliosis has solely been considered a relatively benign spinal condition resulting in spinal deformity and disfigurement to those afflicted by the disease. With this book, I hope to begin to expand and reshape how this condition is viewed, evaluated, and eventually treated to yield better treatment outcomes, assist those living a lifelong journey with the condition, and identify those genetically at risk in hopes of preventing the condition altogether. This is my dream. This is my passion. This is my mission. Introduction. The 19 most common scoliosis genes and what you can do about them. If you or someone you love has been diagnosed with adolescent idiopathic scoliosis, AIS, you know how confusing and overwhelming it can be. AIS has long been labeled as a condition without a clear cause, leaving many families searching for answers. However, recent advances in genetic research have shed new light on this complex condition, revealing that certain genetic variants play a major role in its development. In this book, we take a deep dive into the 19 most common genes linked to scoliosis. Each of these genetic variants affects crucial body processes, from digestion and hormone metabolism to neurotransmitter production, bone development, and detoxification. When these processes are disrupted, the delicate balance required for healthy growth and posture can shift, setting the stage for scoliosis to develop. What makes AIS particularly challenging is that it rarely stems from just one gene or one disrupted process. Instead, it emerges from a combination of genetic variant patterns, each one subtly influencing the body's structure and function. It's the cumulative effect of these genetic interactions that can lead to the curvature of the spine typically seen in adolescents. Understanding your genetic makeup doesn't just provide insight into why scoliosis occurs, it also opens the door to proactive steps you can take. By identifying and addressing the specific body systems impacted by these genetic variations, there are ways to support the body's natural healing processes and improve outcomes. Throughout this book, you'll not only learn about the specific genes involved in scoliosis, but also discover practical strategies for mitigating their effects. Our goal is to empower you with knowledge, to help you make informed decisions about your health, your care, and your future. Let's begin the journey into the genetics of scoliosis, and more importantly, into the possibilities for hope, healing, and strength. How can results from genetic testing improve scoliosis treatment? Genetic testing has the potential to greatly improve scoliosis treatment by offering a more personalized approach to care. By identifying children who are genetically predisposed to adolescent idiopathic scoliosis, AIS, preventative dietary and supplementation plans can be developed to support healthy growth and potentially prevent spinal curvature from forming during critical growth periods. In addition, genetic insights can help predict which cases are at higher risk for curve progression, allowing for targeted nutrient therapies designed to slow or halt worsening during adolescent growth spurts. Beyond adolescence, Understanding these genetic factors can also improve the quality of life for adult scoliosis sufferers, as the same genetic variant patterns that contribute to spinal curvature often have broader negative effects on overall health throughout a person's lifetime. What is a genetic variant, and how does it affect adolescent idiopathic scoliosis? Adolescent idiopathic scoliosis, AIS, is the most common type of scoliosis, affecting children and teens between ages 10 and 18. The term idiopathic means the exact cause is unknown, but genetics play a significant role. A genetic variant is a change or alteration in the DNA sequence that makes up a gene. These changes can range from a single nucleotide, building block of DNA, to large segments of chromosomes. Genetic variants can be benign, having no effect, pathogenic, causing disease, or of uncertain significance. We don't know yet if they're harmful or not. Epigenetics and environmental interaction. Some variants may make the genome more sensitive to external factors, like rapid growth, hormones, or mechanical stress. This is why not everyone with the same variant develops scoliosis. The expression can depend on environment and timing. How genetic variants affect AIS. Predisposition. Some genetic variants increase the likelihood that a person will develop AIS. These don't directly cause scoliosis, but make it more likely to occur under certain conditions. Curve progression. Other variants may be linked to how severe the curve becomes over time. Biological pathways. Identified variants often affect genes involved in bone growth and development, digestive function, neurotransmitter production, hormone metabolism, and detoxification. How do genetic variant patterns cause AIS? Understanding how patterns of genetic variants contribute to idiopathic scoliosis, especially adolescent idiopathic scoliosis, AIS, involves looking at how combinations of multiple variants influence biological systems that are key for spine development and maintenance. Idiopathic scoliosis is considered a complex genetic disorder, meaning it's not caused by a single gene, but by multiple variants acting together, often in subtle ways. These variants can influence various biological systems. Here's how. Polygenic risk and cumulative effect. AIS is polygenic. Many small effect variants work together. Individually, these variants may not cause scoliosis, but together they tip the balance toward abnormal spinal curvature during growth spurts. Disruption in developmental pathways. Skeletal development. Genes variants may affect bone growth rate, vertebral shape, or mechanical strength. Abnormal growth or asymmetry in vertebrae can lead to curvature. Neuromuscular control. Some genes influence proprioception, awareness of body position, and postural muscle tone. Variants that impair neural control or sensory motor feedback loops can lead to imbalanced muscle forces on the spine. Incomplete or ineffective digestion. Lack of specific digestive enzymes can decrease absorption of key nutrients, inhibit neurotransmitter production, or lead to a pro-inflammatory state. Sex-specific effects. AIS is more common in females. Some genetic variants may interact with estrogen pathways or other sex-related factors, influencing susceptibility. Visualizing it. You can think of AIS as a perfect storm where multiple tiny genetic nudges leads to slightly altered control systems and uneven bone and spinal cord growth causing a spinal curvature during adolescent growth. What are the 19 most common scoliosis gene groups, and what do they do? As of when this book is being written, we have identified 28 genetic variant groups. More may be discovered as more data becomes available as AI programs continue to evolve. However, purposes of this book, we are looking at the 19 most common genetic variant groups related to adolescent idiopathic scoliosis. It should be noted that the frequency at which a genetic variant group in the idiopathic scoliosis population is found does not necessarily equate to how consequential it may be in the pathogenesis of the condition. For purposes of ease of understanding and simplification, I have categorized each of the 19 genetic variant groups into one of 5 categories in no particular order of importance. 1. Digestion. 2. Hormone metabolism. 3. Neurotransmitter production. 4. Bone development. 5. Detoxification.